All right, so let's do 4.3, and this is the first part of it where they have these word problems. And these are very, very popular ACT problems. If you've taken the ACT or the practice ACT, you've definitely probably seen some like this. They're really not that bad. They just look really scary, but once you actually start doing them, they're not bad. So let's start with the first one. The equation of the motion of a projectile fired straight up at an initial velocity of 64 feet per second is, and then there's that equation, where h is the height in feet and t is the time in seconds. So this graph, on all these, I like to sketch a little picture of what it looks like. So this is let's talk about the parts of it. So since the A is negative, we know it's going to be a upside down parabola or a sad face parabola, right? Because A is negative, okay? So where does that graph, so let's just figure out all the pieces and then we're just gonna graph it to give us a sketch. So first, let's find the axis of symmetry. Okay, so just like we've been doing before, this is in standard form, so this is how we have to do it. That your x is negative b over 2a. So that would be negative times 64 over 2 times negative 16, which would be negative 64 over negative 32, which equals negative divided by negative is positive, and that would be positive 2. Okay, so that's our axis of symmetry. Let's figure out what our y-coordinate of the vertex is. So let's write this, x equals 2, put that down. And so we're gonna have negative 16 times 2 squared plus 64 times 2. Okay, put that on a calculator, and you get 64. So your vertex is at 2, 64. So there's the other thing we're gonna graph. And the last one is the y-intercept. Well, the y-intercept is your c, and there is no c on this one, right? So if there is none, your y-intercept would be at 0, 0, because that means the c is 0. So let's sketch a graph. So we know it starts at 0, 0 on the y-axis, and then the axis of symmetry is at 2, and we're just kind of sketching a graph. The vertex is at 264, so it's about right there. So this, oops, that's really bad. So this graph looks something like this, okay? So let's talk about this, what all the pieces mean, okay? So this is where it starts, right? So it starts at 0, it starts on the ground, and then this is where it falls, or we'll put lands. Okay, this is your maximum height, right? And then also we should talk about, and this one I didn't mention, I should have at the beginning, it says h of t, you probably noticed that. H of t, where h is the height of feet, so that's like your y, and your x in this equation is t, so this is going to be your t, the bottom is going to be your time in seconds, so I'm going to go ahead and label that. So this would be seconds, and your y-axis is your feet. Okay, so now that we have it all done, we just need to interpret the graph. Okay, so at what time does the ball reach its maximum height? So the maximum height is going to be at 2, right? Because it's time, so that would be seconds, so it'd be 2 seconds, because here's the max and it occurs at 2 seconds. And then what is the maximum height? Well, what is it right there? Well, it's going to be 64. So let's go 64 feet. And so on this one, it's a little bit different. At what time does the projectile hit the ground? The next one we do is different than this one, but since this one's easier because it starts at 0, 0, and since these are symmetrical, if it is, it's colored, 2 away here, since it's symmetrical, it's going to be 2 away here. So since this is 2, since this is 2 and this is 2, this time right here would be 4 seconds. So that coordinate would be 4, 0. So what time does it hit the ground? At 4 seconds. Okay, so that's, I mean, these problems are just interpreting what it all means. Okay, let's do another one. Hold on just a second. I'm going to pause the video and clean this up a little bit. All right, so let's go ahead and do this. So we have another one. So an athlete whose event is the shot put releases the shot, whose path can be modeled by that equation. We have some decimals in there, that's okay. Where x is the shot's distance in feet and y is the point of release in height of the shot put. So I'm going to sketch a little graph. So this is the distance in feet. And then they said the y-axis is the height of the shot put. Okay, let's go ahead and find out all the stuff. So first, let's find your axis of symmetry. Okay, so negative b over 2 times a, which would be negative times 0.4 over 2 times negative 0.02. All right, stick that in a calculator. Okay, and you get the number 10. So our axis of symmetry is at 10. All righty, and then let's see our vertex. Your y is, we're going to plug that back in for the x in the original problem. So negative 0.02 times 10 squared plus 0.4 times 10 plus 5.5. Stick that in a calculator. Okay, and we get 7.5. All right. So then our vertex for this problem is 10, 7.5. All right, and the next thing we're going to find is the y-intercept. So the y-intercept on this is 0, c, so 0, 5.5. All right, so this one is a little different because, and the reason why I say it's different is because the y-intercept is not 0 like the last one, but as for now I'm just going to go ahead and plot all of this stuff. So we have our axis of symmetry is at 10. Oops. So here's 10. There's that. And then our vertex is at, what was it, 10, 7.5? They didn't throw it very far. That's okay. 10, 7.5, which would be right there. And then our y-intercept is 5.5. Here's 5.5. Okay, so it looks something like this. All right, so we can answer some of these questions, but the letter B, we're gonna have to come back to it, but let's just do letter A. So what is the maximum height of the shot put? Well, the maximum height would be right here. At the vertex, that's the point. So the height would be 7.5 at that point. So 7.5 feet. Let's skip letter B. And then from what height is the shot released? So what is the starting height that it's released? Well, it starts, right here at 0, because this must be the height of the person, 5.5 feet. So the height would be where it starts is 5.5. Okay, so now this next part, I'll do in green. So what is the distance of the throw? So we need to know what this coordinate is right here. And on the last graph, it started at 0, and so it was symmetrical, right? We knew where it would be. But on this one, it starts at 5.5. So if we went to, some people might want to say 20, which is incorrect, because 20 would be about right here on the x-axis, so 20 would be, and so it wouldn't actually be where it lands. So we need to find the x-intercept. Okay, no big deal. Do you know how to find the x-intercept? There is a few different ways to find the x-intercept. So let's just write it. The x-intercept, you have All of the stuff we just took a test over. You could do factoring. You could complete the square. Or, so that's 1, that's 2, or of course the quadratic formula. Okay, so that's how you find x-intercepts. On this one, since these are decimals, I'm not even going to mess with the first two. I'm going straight to the quadratic formula. So for this, our a is negative 0.02. Our b is 0.4. And then our c is 5.5. Okay, so here's a recap of the quadratic formula. Remember, it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that's why I had you memorize it in the last one, because I knew it would come back around again. So let's go ahead and plug all this stuff in. So it would be negative times 0.4 plus or minus the square root of 0.4 to the second power minus 4 times 0.02 times our c, which is 5.5, all over 2 times negative, oh, I forgot there was a negative in that a. Good thing I saw that there. The one messed everything up. So minus 4 times negative 0.02 times 5.5. And then on the denominator would be 2 times negative 0.02. Okay, so let's go ahead and do this. And I'm going to just clean up. I'm going to break it up piece by piece and then do it all. So I'm going to do this piece right here. And then let's see what I get. Okay, so I get, underneath that square root, I get 0.6. And then, so I haven't taken the square root yet, so it's still on there. And I'm going to have negative 0.4 over here. And then on the bottom, that would be negative 0.04. Okay, so remember, you have the positive and the negative version of this. And if you do not use your phone's calculator, I would definitely use the Desmos calculator, or if you have a legitimate like scientific calculator or graphing calculator, whatever you have, just don't use the Apple or Android calculator because they aren't good at order of operations like this. Okay, so I'm going to do two different things. I'm going to do negative 0.4 plus the square root of 0.6 over negative 0.04. And then I'm going to do the negative version, which is the same thing. It just has a minus sign in between. Okay, so go ahead and stick those in your calculator. Please do it just to practice solving. Okay, so whenever I did the plus version, I got negative 9.3649 ... and then the other one I got 29.3649. Let's just go ahead, since it doesn't specify in the directions what they want us to round it to, let's round it to the nearest tenth, which is 1 decimal place. So this one is negative 9.7, because you're rounding to the 3, so you look up at the 6. Does a 6 cause the 3 to go up or stay the same? Causes it to go up. This one we're going to do, it's going to be 29 point something, so we're looking at the 3. Does it go up or stay the same? Well, this 6 also makes this go up, so it would be 29.4. Oh, I just realized I messed up on this other side. Sorry, I'm struggling. That's not 9.7, it's 9.4. The 6 causes 3 to go up to 4. All right, so now we have our two x's. So let's go ahead and plot those points on our little sketch. So we know this one is 29.4, which makes sense. That's a realistic number. And then the other one was negative 9.4. So if this continued on, it would be at negative 9.4. Okay, so what is the distance thrown, or of the throw? Well, if it started at 0 and ended here, what is that distance? That would be 29.4 feet. All right, that is it for this first part of this lesson.